The focus of our project is to accurately quantify the rehabilitation of patients who have undergone ACL reconstructive surgery. ACL injury is one of the most common types of knee injury, leaving those injured with a lengthy recovery period and a high risk of re-injury. The intended users of our system are clinicians involved in sports therapy. Our project utilizes thigh angular velocity as a parameter to measure the progression of ACL rehabilitation using APDM inertial sensors. Our project will measure, record, and save sessions of data acquisition. It will then produce a visual report of ACL recovery progression while maintaining a presentable user interface for clinicians.
Our program incorporates the use of a database which houses both patient information and recorded data. It is from this database that we can retrieve information in order to analyze particular sets of data and generate patient reports. A first-time user may create a new profile in the program by entering various pieces of information. A user who already has a profile within the program can retrieve that profile. Once a profile has been created or retrieved, the user may begin testing.
This program uses an Opal device system, which can wirelessly transfer data. First, dock the two monitors that you'll be using, then select Configure. Once the light turns off, select Device Info to make sure the monitor IDs are correct. You can now begin the process to record trial data. Each device must be correctly placed on the participant, making sure that the numbers are facing outwards and the data imports are facing down, with the shank and thigh placement correct. Next, you then measure the tibia length. Once you get this, we'll make sure that every participant has their own reference jump. Then you can begin. So the idea is you're leading off with your left leg or the leg not being tested, and you then jump on your tested leg. You will then do this jump 3 times. Once you have completed 3 trials on your healthy leg and recovery leg, you can now do analysis on each trial. From here, you can select which trial you've just completed. Once you select which leg, data will appear. You select the second jump within each trial, since it's consistent throughout each individual's trial data. Once you set cursors, you can find peak angular velocities, and you can now save data. The data can be saved and removed, and now you can go to report. You can select your report from your folder, and it will appear. This shows your patient information along with the progress of your thigh and knee angular velocity in comparison between your injured and healthy leg, along with a plot of progress for state of testing. So over multiple test periods, you can see your progress in the graph.
Our goal for this project was to create a program that is user-friendly and relevant to clinicians and recovering athletes alike. Looking back on the development of our program, we are particularly proud of our ability to 1. Assure that all components of our program are user-friendly, which is made possible by consistently following up with actual practitioners. 2. Develop LabVIEW code to show real-time data, which required developing new code in order to configure with Opal devices. 3. Produce a simplified format to analyze data retrieved during a 3-hop test. And 4. Create a comprehensive database to save and retrieve patient data. We hope that our project will improve current recovery evaluation methods and ultimately reduce the risk of re-injury for those recuperating from ACL reconstructive surgery.